Hi, good evening everyone. By the way, I am Mr. David Jan Razonado Limbin, BS Ed2 student, major in mathematics. So this evening we will discuss about similarity and Pythagorean theorem. So Pythagorean theorem. This theorem states that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the square of the leaves. So, just for example, we have the right triangle. So, this right triangle, we can call this a right triangle because it is a 90 degrees here. 90 degrees. So, we can name this triangle as a triangle, triangle A, B, C. Then, the opposite of the right triangle is the hypotenuse. So, this line AB, we can call this as a this side, rather this side is, we can call this as the hypotenuse. Then this line also, line C, we can call this as a lowercase, and the opposite of this angle A is the lowercase a, and the opposite of this angle B is the lowercase b. So from the statement above, that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the square of the legs. So C is our hypotenuse, so C squared is equal to the sum of the square of the legs. So A squared, B squared plus B squared. So that's our formula in Pythagorean theorem. So now we will extract the square root. It becomes C equals square root of E squared plus D squared. So what if we are looking the value of A? So the formula, we will extract the formula, and we will derive the formula. It comes out that A A is equal to A squared is equal to C squared minus B squared. Extract the formula, it becomes A equals square root of C squared minus B squared. Okay? And what if we are looking for the value of this side, the side B? So B squared is equal to C squared minus A squared. We will extract that square root, so it becomes B is equal to the square root of C squared minus A squared. Okay? So now we will have an activity for you to learn more and understand about Pythagorean theorem. So here are the activity. So I will put this. So just for example, this right triangle. Right triangle QRS. So now we will find the S, the hypotenuse or the side S, if the value of our Q is 3 and our value of our R is equal to 4. So by using this formula, C is equal to the square root of E squared plus B squared. C is equal to the square root of Q. So we will change that into S. So S, which is the hypotenuse, and our Q. Q squared plus R squared. Okay? So by deriving the formula and by substituting its value of the side, so it becomes S is equal to the square root of Q. The value of Q is 3, 3 squared plus our R is 4, 4 squared. So is equal to the square root of 3 times 3 is equal to 9 plus 4 times 4 is 16. So S is equal to the square root of 25. So our S is equal to square root of 25 is 5. Okay. So how about number 2? Q squared is equal to S squared minus R squared. So the value now of our Q is equal to the square root of S squared minus R squared. Then substitute the value of R and S. So Q is equal to the square root of 10 squared minus 6 squared. So Q is equal to the square root of 100 minus 36 is equal to the square root of 64. And the square root of 64 is 8. So the value of our Q is 8. Our Q is equal to 8. Now, take a look. In your seat or in your position now, take to solve this number 3. Find R if our 8 if our S is equal to 8 and our Q is equal to. So now, let's proceed to the similarity theorem. According to the theorem, state that in a triangle, the altitude divide the triangle into two triangles that are similar